Hello everyone, we'll go with group 16 elements. Without using board, whatever the points we can remember, all those lines I would like to mention in this lengthy video. Okay, so first oxygen, sulfur, selenium, tellurium, polonium, okay, and liverpolium. All this, and forget about the LV. Oxygen, sulfur, selenium, tellurium, and polonium. These elements are group 16 elements, P block. General electronic configuration is NH2NP4. They are also called chalcogens. Chalcogens means actually copper ores are available in the form of either copper oxides or copper sulfides. So based on that we can call this as these elements as chalcogens, like mineral forming you can say. Of these, oxygen, sulfur are non-metals. Selenium, tellurium are metalloids. Polonium is a radioactive metal. Polonium half-life, if I am not wrong, 13.8 days. Okay, 13.8 days polonium half-life time. You need to remember that point. Coming to atomicity. Oxygen is a diatomic molecule, gas, colorless, odorless, tasteless, non-poisonous oxygen. Then sulfur, selenium, tellurium all are octatomic. 8 atoms, S8. S8 will be like crown shape. You know, missing the word. Okay, crown shape. Otherwise, chair shape, that is S6. S2 is also possible around 1000 degrees Celsius. S2 vapors you can say, that will be very similar to oxygen. O2 is paramagnetic. Similarly, S2 is also paramagnetic, which is possible above 1000 degrees Celsius. Done. That's about physical states. And atomicity. Oxygen diatomic, remaining are octatomic, bismuth is monatomic. Oxygen and ozone, you can consider them as allotropes. Okay, now similarly, sulfur allotropy is there, very important allotropy. About that allotropic points we'll discuss, okay, in coming moments. Coming to the rest things, oxygen contains double bond and sulfur atoms will be having all single bonds between them, SH, SE8 and this. Coming to the atomic radius, down the group atomic radius should increases. Ionic radius should increases. Ionization potential should decreases. Electron gain enthalpy is the most important exception, where oxygen is at last. Again, oxygen should be the best, but oxygen is at last. Sulfur, selenium, tellurium, polonium, oxygen, decreasing. Electron gain enthalpy. Electronegativity, oxygen is the best, down the group decreases. Electron gain enthalpy, oxygen least. Electronegativity, oxygen is the best. Then coming to the remaining properties, densities, down the group increases. Melting and boiling points, if you see, oxygen to sulfur to selenium to tellurium increases, tellurium to polonium decreases. Increase, then decrease. Oxygen is very minimum because it's a gas. That's about melting and boiling points, densities, general properties. Oxidation states. Oxygen is non-metal, so it can show -2 oxidation state, -1 in peroxides, -of in superoxides, and what you can say, -1, -of, +1, +2 in OF2 and O2F2. OF2 +2, O2F2 +1. Positive states are also possible. O2, O3, 0 oxidation state. Sulfur, if you see, -2 is possible, like H2S case, and +2 is possible in the ground state. +4 and +6 are also possible. +4 in the first excited state, +6 in the second excited state. +4 and +6. And higher oxidation state stability as well as negative oxidation state stability, down the group decreases. This is for all groups, nitrogen group or carbon group, hydrogen group you can see. Here oxygen -2, sulfur -2, remaining elements generally they don't show -2 because they are not non-metals. Higher oxidation state stability also decreases. Further, the reason you can say inert pair effect. The reluctance of NS electron pair to take part in bonding is inert pair effect, that is much pronounced in the lost elements like thallium, lead and all. Coming to the oxidation states, and when intermediate oxidation state is there, that can undergo, that particular species can undergo disproportionation, like SO2. It can go to S, it can go to H2SO4. Disproportionation is possible. S2Cl2, disproportionation is possible. So this is about the general introduction of chalcogens. Coming to the groups, um, coming to the properties, not groups, coming to the properties. First, hydrates. Hydrogen oxide H2O, hydrogen sulfide H2S, hydrogen selenide, hydrogen telluride, hydrogen polonide you can take. Here 4-5 important lines you need to remember. Down the group, that means H2S to H2Se, H2Te, H2PO, first H2 water, H2S, H2Se, H2T. If this order you see, bond length increases because size increases, so bond length increases. When bond length increases, bond energy decreases. So water bond energy more, H2PO bond energy is less. Bond energy decreases. When bond energy decreases, obviously stability decreases. So water is more stable, H2PO is less stable. These lines are very simple. Water, oxygen hybridization is sp3, so the bond angle is 104.5 degrees. Water bond angle 104.5 degrees. Whereas remaining elements, if you see, like sulfur, H2S, H2Se, H2T, when they are forming 92, 91, 90, close to 90 degrees. The reason is very simple, due to the pure orbitals participation. In water sp3, here pure orbitals bond angle is going to be 90 degrees. Okay, so 92, 91, 90. Then two important points, bond angles are over. The next point is acidic nature. Water is weak acid, Ka value is also very less. When you are going up to H2PO, the bond energy decreases, so the acidic strength increases. Water is a weak acid, H2S is a better acid, and down the group the acidic strength increases. So Ka value is also increasing. Acidic strength down the group increases. One interesting point is reducing ability. Reducing nature. Water is not a reducing agent. Remember this point. Water is not a reducing agent. Water is not a reducing agent. Remaining elements. Remaining elements down the group again bond energy decreases. So the reducing ability also increases. In fifth group we discuss reducing nature and Lewis base character. Here we are discussing reducing nature and acidic nature. Reducing nature down the group increases. Acidic nature also down the group increases. Okay. About this H2S and all in special classes we'll discuss. So this is about the general introduction, general information of the group elements and hydrates. Next video we'll meet with oxides.